Welcome to the online presentation about Windows 10 hardware architecture and hardware management. Let's get started. So last class we talked about user mode versus kernel mode. This is a more detailed drawing than we had last time when we talked about software architecture, but it's also a bit older if you noticed Microsoft Windows 2000, right? So for the accreditation down here. So anyway, but the important thing is this, right? We have a user mode where things can run, applications can run here. ntdll.dll is the actual DLL that kind of manages these checkpoints between the two modes. We have various modules running down here in the kernel mode. These modules, these memory managers and plug-and-play manager are very important. We have this thing called the hardware abstraction layer, HAL. Probably a strong reference to 2001, is kind of the weird place where the digital world interacts with the physical world. This is the kind of layer where drivers can go through the HAL to interact with a machine. All right. And so that's what the hell is. DLLs. Now let's talk about DLLs. So system DLLs are the actual driver link library, or dynamic driver link library, as they're called. It's kind of bundled up code. You're going to have system DLLs, like ntdll.dll is a very core system DLL that's going to be very well protected. But also programs themselves can have DLLs. Sometimes drivers will have DLLs, and that's going to be the hook. All right, so it's important to know this, that, like, case in point, this application. The application is recording my my talk right now. Screen Grab-O-Rama, as it's called, has probably a DLL. It could also be using an API, but it's probably using a DLL that gets its hook into the operating system, and through the operating system, going through user mode and kernel mode, going through ntdll.dll, gets access to, in this case, my microphone, right? The microphone itself. That microphone is the input coming in from it. It then goes back through and it goes to the application. Okay, so the application has to go through the operating system to get it. It can have DLLs, right? It can have the DLLs. There's also Windows DLLs, and there's down here there's DLLs as well. All right, but DLLs are system files. They're direct code to use the operating system. All right. Processors, we kind of talked about this before as a quick review. Multitasking is the ability of an operating system to switch between processes so quickly that that the user shouldn't notice that it's only working on one at a time. So you can have a video playing the same time you're doing a Word document, right? We have preemptive multitasking. That's kind of a more of aggressive, to boil it down and make it really simple, it's just a more aggressive form of multitasking, giving more time to real-time apps, that video sharing or video streaming and calls and Skype and real-time processes, giving more attention to that. Multiprocessors, you can have you can have a motherboard that has multiple processors on it. Again, if there's multiple processors, the operating system is going to have some kind of process. Here's the operating system that's going to have to, so there's our multiprocessor, that's going to have to take that thread, right? Here's the thread generated by the operating system, but then split that thread into two, okay? And yes, there's overhead to it. And then after they're done working on it, the operating system needs to take those threads in again and put them back together. Okay. Along the same route, we can have those multiple processors can have multi-core, right? You can have two quad multi-core processors, and that way you have 8 cores in your PC. Okay. Not unheard of, especially on server devices. Okay, would be a little weird on a laptop. It'd have to be a rather big laptop, but there you have it. What's going on here is the processor itself then takes that thread. It's going to divide it up and put it off to these 4 processors, and then take the output from those 4 processors and put them back together. All right. Again, a little bit of overhead, but because of power consumption, because of heat power consumption and heat production. Multi-cores is the way to go nowadays. All right. Processor affinity. So what can happen with processor affinity if you have multiple processes going on in a computer and it doesn't catch it, and the operating system doesn't catch it, it does look for it, it tries to avoid it, it'll kill a process if it detects it. But if you have it set up where you have multiple processes going on at the same time, and process A is working with process B, it happens all the time, multiple processes interact with each other. If process A interacts with process B, and process A needs process B to finish before it can do its job, right? It needs some kind of variable or something from process B. However, process B needs some kind of variable from A after when it finishes. When it's done, it's going to give it a variable so it can finish. So what you end up with is this kind of deadly embrace, as it's sometimes called, where the two processes need each other to finish in order for them to finish. So you're stuck, catch-22, right? So you're stuck. That's in a nutshell, processor affinity. All right. Multi-touch on tablets, phones, you're going to see more and more multi-touch. That is a big deal. This whole, and also we have it with our touchpads too. You can scroll down with 2 fingers, or you can zoom in and zoom out with, I'm playing with my trackpad right now, which I probably shouldn't be doing. But you can zoom in and zoom out by, stretching your fingers or pinching, right? Let's talk about plug and play. So the way plug and play is supposed to work, right, is when it's a process, all right, a little bit more honorable perhaps than the Philadelphia process, but what happens is plug and play's job is this. I got some kind of hardware, whatever, hardware X, okay, and when I plug it in, they'll make it USB. When I plug it in, it needs to report, first of all, to Windows and say, hey, Windows, we're talking about Windows 10 here, so let's put a Windows 10. Hey, Windows, I am this type of hardware. Now, that's obviously a little tricky because the manufacturer of X needs to know what Windows is expecting, and we can see that. So Windows 10 then has to assign a number of resources, depending on what it needs. Let's say this needs an interrupt request to IRQ. That's going to give it the ability to interrupt other devices. That's going to be that'll be a hex. It's going to need the I/O number. That again is giving it an input/output. Priority. Again, oversimplification, but there you go. It's an order for I/O. And then let's just say it's going to need a memory range too. That's dedicated memory to my device. All right, and Windows needs to sort all this out with all the current devices and put that device somewhere in here along with the other devices so it can work. Okay, that's plug and play in a nutshell. And it needs to load up the drivers, right? So it's going to get this hardware ID, right? We're going to see this. It's going to need the hardware ID. Okay, that hardware ID is going to tell Windows 10 what driver to look for. Ideally, Windows will have in its driver store, its local driver store. Okay, and if it doesn't, then it might have to get downloaded out to the internet or something along those lines. All right, let me bring up my my virtual operating system, and we're going to look at Device Manager. We're going to talk about it right now anyway, so let's bring up Device Manager. I right click. I could click go directly to Device Manager. We'll do it that way this time. It comes up. It doesn't give me an error message because I'm in as administrator. I'm in as CIT 120 admin, as you can see somewhere. I guess that's weird. Anyway, I'm in as CIT admin. Oh, here I am. It just doesn't list it. CIT 120 admin. So it doesn't yell at me, but which it would if I was a standard user. Here's a list of the categories of my different hardware. If there was a problem with any of the hardware when I just brought it up, and let's do that. I'm going to disable this driver. So I can right click and hit disable the device. I can disable it there, or I can press this little down arrow button. Do you really want to disable it? Sure, it's a COM port. Who really cares? I'm going to close this out. I bring up the other version of Device Manager. Whoops. Which go through computer management. We have I'm going to bring out the Microsoft MMC This is the Microsoft Management Console. That's what MMC is short for. It's customizable. I can add things over here. I can take this away or add this. I can shrink it, all that good stuff. That's what we mean by customizable. All right. Anyway, so I go back to the device manager. Device manager. Notice when it popped up, by the way, the communication port was right here. Okay, it was loaded up, and it wasn't compressed in there. And the reason why is because it's down, so it's kind of drawing my attention to it. All right, I can bring it back up here too. There we go. There you go. Going back to this is going to have IRQ and an IO under resources. Yep, there's my IO range, and there's my interrupt request. All right. Now, when it first comes up, let's pick on a mouse, because mice are there's lots of different mice. So when this device first came up, we'll go USB pointing device. That's the mouse I'm currently using. And I go to details, and I have hardware IDs. These IDs that came in, this is what the device reported to the operating system. Say, hey, I'm just a system mouse, or I'm a device. Based off priority, by the way. I'd prefer most to use this specification, but as you can see, it gets more and more generic as we go down, right? Well, not necessarily. This is and we're trying different names. So these are the things we reported to the operating system. This is what I am. Based off of this, give me a device driver, okay? And again, I'm going to get hardware or resources appointed to me. Just to show you what it looks like, I'm going to bring up the display adapter. The display adapter will have more resources, particularly memory range, because it's a very active thing. It needs its own memory. It's going to have multiple I/O ranges, and it has a single IRQ. Again, all this gets assigned to it automatically now with Plug and Play in Microsoft, and it does a much better job than it used to. I can tell you that as well. Oh, I know. Yep, there we go. So, all right, so here's Device Manager, and we talked a little bit about Plug and Play. Now, a big important thing about Plug and Play is that we need the Device Manager. We need the device drivers on this machine. If we don't have the device drivers in the Microsoft Store, the local store of the device drivers, it's going to want to get device drivers loaded up before it can do any work. So we'll get back to that. Well, we're going to bring it up right here, actually. So some other things about drivers. All 64-bit drivers that run in kernel mode must be digitally signed. Again, most device drivers are going to run in digital mode, kernel mode. The only ones that really don't are printer drivers. Printer drivers must run in user mode. All right. Network drivers must be NDIS. Network driver. What is that again? I don't remember off the top of my head. So, network driver interface. That was a network driver interface. So must be network driver interface standard 10.0 or higher. Printer drivers must run in user mode. To upgrade or not to upgrade, we'll talk about that in a sec. So again, in order for Plug and Play to work well, ideally the drivers will be, or some driver that will work with it, will be in Windows Store. So sometimes as an IT staff, particularly in like a small business environment, or where you don't have a whole lot of users, it'd be nice to have, and if there's a printer everyone needs to plug into locally, it's a local printer or something along those lines, it'd be good to have drivers in there that work, so you can actually add drivers to the printer store. You do that by going to using PNP util. If I bring up my PowerShell here, I type PNP util, it's going to give me all my options here. All right. Again, it's just a utility. What I do is I feed in file names of an inf of a driver file, and I can add that driver. I can delete drivers from my store. Again, local cache is a good. When I say store, I mean the local cache of drivers. Okay. And that way, when the user plugs in, the drivers are already there. And Windows Plug and Play can just work without users installing drivers, which they may not have the ability to do because they might be in a standard users. Even if they have the ability to do it, users tend not to like to install drivers. So it's a nice little utility to have. We looked at the Microsoft Management Consoles, customizable framework for administrative tools, device manager, MMC to manage hardware in a system. We showed that you could check function, modify resources, upgrade, retrograde drivers. So that goes back to this upgrade or not to upgrade. A wily veteran in the IT department tends not to upgrade drivers because they have experienced that sometimes it's causes more harm than it helps, right? So it's not, sometimes you have to do it. You might have a device driver that, whatever reason, the application is not playing nice with it. You have an upgraded driver. It might be a security patch. There might be something you need to upgrade for security reasons. It's another device driver. But any any person's been around the block a couple times in IT will cringe when you want to upgrade drivers, right? Because, again, drivers are so deep in the system, right? Going back to this picture here, most kernels, system kernels being 64-bit, they're so deep in the system that it causes a bit of a ripple effect, right? You're affecting all applications possibly, right? You could cause all kinds of problems by upgrading drivers. Blue screens of death, right? Most people prefer not to upgrade. Okay, so another thing you can do, by the way, is also you can retrograde drivers, right? If you upgrade device adapters, a good display adapter is a good example. If I upgrade a driver, I can also roll back the driver, right? So I can update, I can roll back, I can also disable a device and uninstall a device. All right. Let's move along. Also, exclamation points are bad. Exclamation points usually means there's a conflict or something's wrong or we can't find drivers for it. Let's talk about power management. So all devices need to be, all peripherals must be ACPI, Advanced Configuration and Power Interface Compliance. That is the rules of the game, the protocol in which everyone agrees to talk for power management. So again, a big part of operating systems, because a lot of them are installed on laptops, is power management, right? That people don't want to be charging their laptops all the time, right? So the operating system would prefer to tell a mouse to decrease its sample rate. That way you're saving power. It would prefer to tell a wireless card not to transmit such a high power, to save some battery, right? So it needs to interface with lots of different devices, okay? We have S0, which is, so let's talk about the different power states, okay? This is just a general broad specification, right? S0 is working up, everything's up. S3 is sleep, which means we take the operating system that's in RAM and we just keep that we take a snapshot of that and we keep it in RAM, okay? Which has its advantages because RAM is fast. So when we come out of sleep mode, it happens really quick. It's almost like we're just turn the screen on and we're already there, right? When I say take an image, right, we're going to have our operating system running, right? We're going to have, let's just say Win32 apps right here, and so it's a segmented part of memory. We're going to have some other apps running here, right? We're going to have all these sectioned off parts of memory. And when we take a picture of it, we're kind of like, okay, there it is, right? The downside is, remember, this is volatile memory. So when the power goes out, all that data is going to be gone. And when I say app, by the way, I mean like any unsaved data too, right? So this is a big deal, all right? There's S4 sleep, as we call it in Microsoft world, we call it hibernation, right? What we do in hibernation, I'm going to draw a cylinder for storage. So what we do is we take we take an image of this memory and we copy it over to storage. Okay, so that way we can save power. We don't have to power up, keep the RAM powered up, right? That's a good thing. And we save an image of that memory running in storage. That way, when we come up, we're going to have to come out of storage, which is it's a lot slower than coming out of S3 sleep because we have to take it out of storage and slap it up here. But it's much faster than actually booting up an operating system, where we're going to have to take the files out of here, process them, reestablish them, start services, do it in the right order, decompressed file. If you ever look in your Windows files, there's lots of cabs. cabs are compressed files, right? So we'd have to decompress all those files. That takes a lot longer. S3 Sleep is faster loading time. It's faster for loading time as a plus side, but power, it's no good. All right, it takes up too much power, right? In this case, this is slower. That's not good. We don't like slower, right? But power, it's good. It's got better power. So it all depends on what you're doing. If you're just shutting your laptop for 5 minutes, you have to go take care of something and then come back to your laptop. That's what S3 Sleep is for, right? If you shut it and you suspend it for a long time, like 24 hours, that's what the hibernation is for, right? And you don't mind it coming and taking a little bit longer to come up, right? So ideally we could have best of both worlds, and that's kind of what Windows Hybrid Sleep tries to do. If you close your laptop initially, it's going to go to S3 Sleep, and then once it's been closed for X amount of time, and that's in the power settings, which we'll look at, once you keep your laptop closed for X amount of time, it will kick over to S4 Sleep. It will start running off the image on the hard drive. But here's the problem. It can't do that. It can't make the image of the memory and put it in storage without the operating system being up. So what it does is when it goes to sleep, just normal sleep, the process takes a picture of the memory and then puts it over to storage. When it goes from S3 to S4 Sleep, it just kills the power, right? That power coming in, it just kills it to the memory, losing this, but we still have what's on storage because storage doesn't need power to keep its data. So that's how it goes from S3 to S4, even when it's in S3 Sleep. That's Windows Hybrid Sleep. Even if you're just going to sleep, it goes to sleep, but it also takes a copy. Part of the going to sleep process is it takes an image, picture of the image, and stores it in storage. Okay. We have soft off, which just means the system is down, but we have any hardware needed to reboot the system, like Wake on LAN, for example, is a good example. And then we have hard off, which just means we have no systems up and running. Okay. All right. Modern standby. So Windows 10 will do if the hardware supports it. Computer is actually the S0 state, so it can perform background tasks. What that's referring to is, let's actually see, power CFG. I don't know if I'm cap lock, but yay, PowerShell doesn't really care. The following sleep states are available. Hybrid sleep, hibernate, standby S3, and fast startup is all available. Okay. Are not available. They're standby S3, low power idle. So that's what they're referring to there. All right. So, Modern Standby, again, this is valuable for administrators if we want to run updates while the machine is somewhat in a sleep state, but it's actually up enough that can do processes in the background. All right. Fast Startup, what I just was talking about. Fast Startup says essentially Microsoft looked at that, is always looking to increase startup time, and one way they could do that was instead of initializing the whole hardware operating system like we just talked about, we can just simply tell it to take it on memory. What we do is we make an image, or we make an image of the memory, put it on storage, and we just load up that image instead of redoing the whole operating system. But if we do that, we're just grabbing the operating system, right? We're not grabbing all the apps. So here's memory, right? Again, we have that segmented part of the operating system, the kernel system, right? This is all the important stuff of the operating system. This is what we take the image of this part, okay? All the apps and everything else will get shut down. It's just the operating system, and we'll just load that back up instead of actually booting up the operating systems fresh. There's parts of the operating system that won't get snapshot, like services, or a lot of services, because it's just faster that way. It's built for speed. Okay, if you want to force your hand and make it do a full shutdown, you can do that by typing. There we go. By typing shutdown dash S space dash S. That tells it to shut down. You can do dash R to reboot. And dash T001 to do, and that tells it the time. So I could tell it I want to shut down my box in 60 seconds, in a minute or something. But there you go. The dash S will do a full shutdown. All right. So we have power plans. Let's talk about power plans. So I have been part of those uncomfortable meetings where people argue about silly things like screensavers and monitor shutdowns and all that good stuff. Power settings, the quickest way is just click on Start and type power settings. That's weird. I must have lost focus. There we go. Power settings, power and sleep settings. And you get the the new settings window instead of control panel. So it's not as, I just grabbed that for the whole operating system. I meant to grab it just for this. There it is. Which is not all that helpful. But if you click on additional power settings, you'll bring this up, which is pretty, you have different modes. This one says balanced high performance power saving, which might be older. They might have played with this ever since the October update. Anyway, you can change your individual settings in the plan by clicking change plan settings. Which essentially you get this, which is not all that great. But if you go to change power settings, one thing I do recommend a lot of people do is go to their wireless adapter in both battery and plug-in mode, which you don't have here because it's a virtual machine. It doesn't have a plug-in mode or a battery mode. But if you go to power saving, always set your wireless adapter in both plugged in and not plugged in as maximum performance. I've run into that. Again, part of this too is it's got to interact with the device driver when it talks. This is just Windows going to talk to the device driver. So if the device driver is programmed well and it's set up to interact with Windows and still function correctly and try to save a little power, great, it works. But I bumped into it more times than not. It's a little too dramatic and it's trying to save power, and you lose network performance. It just isn't worth it. So anyway, you can set as what your power button does, and if you have a lid, which this doesn't, again because it's a virtual machine, what that lid does when you shut it. Do you go in hibernate? Do you go to sleep? Do you just turn off the screen? You can also turn off hard disks after a certain amount of time, that kind of thing. All right, away mode is just a special mode in which you have the machine on. It's for machines that are on all the time. And away mode, it won't have any video or audio run. The keyboard and the mouse is filtered, but it will still be in S0 state. All right, let's talk real quick about display adapters in Windows. So we're going to have an application that needs to get access to a video card, right? To do something with the video card, right? There's a number of ways it can do that. It can use either Direct3D runtime, which Microsoft, I think at this point, is preferring. It could use OpenGL, which was written by graphic card manufacturers in an effort to interact better with Windows. And they have Win32 GDI, which is now, it's not defunct, it's still around, quite popular, but it's a low function version of that, right? For higher functions, you want one of these two, Direct3D or OpenGL. All right, but the point is the application is going to interact with these, okay? These programs, services running in the background. Yeah, I guess services. And that service is then going to interact, get through kernel mode, again, get through ntdll.dll, get through this into kernel mode and interact with DirectX. DirectX is a subsystem that runs in kernel mode, and that will interact with the device driver, the display driver. And therefore the display card as well. Okay, so we have multiple steps. You could take Direct3D, that'll interact directly with DirectX. Then we have OpenGL, which goes through a couple more steps, a couple DLLs. Here's a GDI DLL. Then we have Win32, which has a sys file that runs in kernel mode to interact with it. All right. Again, ideally Direct3D runtime or OpenGL would be the way you'd go because they're better written, they have more functions. But if it's just a simple function that you need, you can get away with Win32 as well. Anyway, so the application, and some applications can choose. You can actually set which one you'd prefer to work with. All right. Next, we have Arrow Glass. I should mention Windows 10 had Arrow Glass. You can make windows flip around a little bit. You can put them into a rotary style thing to read it. So anyway, that was Arrow Glass. Display settings. We have screen resolution. So I'll bring that up right here. Oh, there we go. So I can click on display settings and bring this up. I'm going to have, so this changes the texts. I don't know how it got to 120%. I guess it was me doing a demonstration. I wanted people to be able to read in the back of the room. So you notice how the font changed sizes. Be wary though, you're changing the size of things in the windows that might not look as good. Resolution, this is just dots, how many dots on horizontally and how many dots vertically. 1920 by 969. I can change my orientation. I can detect if I have multiple laptops. I can go even deeper. I can go change my screen refresh rate. This is how quickly, if you know those books that flip, that have like a picture of a horse running and you flip through the book and it kind of runs. Well, that you can change that, and some monitors will let you change that. 120 hertz is considered pretty good. Here's the color management screen. I can change my my settings if I wanted to for my color management. So that's display adapters in a nutshell. Let's see here. A couple more things I want to talk about is visual effects. You can do this to help with performance. I've seen some people around my class that their virtual machine is running slow. I might recommend they do this. But what you could do is if you left click or right click on your menu, click on System, then click on System Info. Yes, System Info, and then click on Advanced System Settings, Performance. What you can do is you can make system click on Best Performance or Best Appearance, which is turning on everything, or Best Performance. You hit Apply. The big difference is, I mean, it seems minor, but like when I move this around, right? When I move this window around, you can see a little bit of visual tearing going on. That's when it's moving so quickly that it looks like it's tearing a bit. But you can see the inside of the window. If I hit this right here and hit Apply, I think the text will look uglier. There you go. And when I click and move this, I just get the shadow. That saves a little bit of RAM and helps your performance. Okay, so again, I see some people running a little slow. They might want to give this a try to help speed up their virtual machine. Okay, so there we go. That's visual performance. Visual effects, and desktop background, screensavers, multiple monitors. All right, let's talk about printers and then we're done. So local and sharing. So this is a desktop class. So we're talking about desktop environment. You can share a local printer. So a local printer, predominantly USB nowadays, but back in the good old days, LPT ports or even really old serial ports. But through the serial bus, you are adding a printer peripheral is what's going on, okay? And when you add that printer peripheral, you can then turn around and share it. We'll talk about that when we talk about networking. So we have local printers, which is directly plugged in via USB, versus sharing, accessing it over TCP/IP, which is it's a local link on a different PC. That PC is going to, particularly Windows, will share out. All right. Printer drivers. So back in the day, we only had two. Well, the two predominant printer description languages was PostScript, which was developed by Adobe, and PCL, which is really old. And those were not good days. First of all, sometimes you'd create something in Word, particularly if it was a really complicated document with lots of margins and columns. And once you printed it out, it didn't look the same as it looked on your screen. That happened, okay? But you also had some printers worked better with PostScript, some printers worked better with PCI. Some printers only worked with PostScript. If you had different wrong versions of PCL that the printer didn't support, you could get gobbledygook. All these things can happen. That's less of a problem nowadays because we have PDF, XPS. PDF, again, developed by Adobe. What you see is what you get with PDF. That's the cool thing about it. So if you have a PDF file and you print it out, it will get put on that page exactly as it is there. We have XPS, which is Microsoft's version. They use XML to specify the paper layout. Okay, that's how most printers are going to get to their jobs nowadays, the newer printers at least. We talked about this, again, PNP util.exe, that's used for staging drivers. Very important, right? Because, well, we're talking about the printer driver store. Printers are probably certain printers will only work with certain drivers, okay? So there's not a lot of generic drivers that cover a lot of printers, okay? Drivers are a very specific thing, or a printer is a very specific thing, and the driver needs to be specific to that printer. So staging drivers or getting them in the cache for Windows is really tricky for Microsoft. They don't want to make the install disk too big and have every single driver they possibly can. So going through your company and using PNP exe could help get those printers on workstations faster. So printer management, that's the utility. That's I keep trying to switch that way. It's just not the way it's supposed to do it. If you do, I have it. I'm going to go to well, settings. I can get to this little gear here. Let's look for devices. Whoops, I went there a little too fast. Printers and scanners. There I am. I don't have a lot of printers. That's supposed to making me a little hesitant to try this. But let's try using one of these. So these are built-in software printers that will you can send a print job to it, and it will save it as a PDF or a document writer. So let me click on this. I'm going to click on print to PDF, manage, and so this is the big Microsoft one. I can print to PDF. I can print a test page. I can look in printer properties. These are the properties of the printer where I can change various options that I have. You can't share it out, but this is where I could share it. I can change the printer driver, or printer port, excuse me, this is the port that it uses. So LPTs are the old printer ports. So just FYI, this is you can change ports here. You can limit when people can print to it. You can change the color management, and you can actually lock it down with some security with the access control list. So there you go. There is an old school printer interface too, which I don't have because I don't have a printer installed. Yeah, all right. And that we'll talk about that. So printers and scanners from devices and the settings screen. You can add or move printer, manage spooler, print test page, and also set default printer too. That happens sometimes. Users get a little excited, change their default printer, and then they don't know where they're printing. All right. So we have also a printer MMC snap-in. Again, we can have it on the side effect. I don't have it again because I don't have a printer on mine. But you can manage multiple print servers if you want. That's really what it's for. All right. This is what we just went through with the printer configuration. Printers are a hassle, but users think they're necessary. All right. So that covers everything in the presentation. So I hope you found this useful, and I'll talk to you later. Bye.